Hi everyone, my name is John Cedillos, and today we're going to be going over some troubleshooting and OSPF, also known as open shortest path first. So, our packet tracer, we're going to start right now. So, this down, oops, right here. Okay, so, see these two links are down. The gigabit Ethernet 000 and 001 on router 1, 000 on router 5. So let's see what's going on with that. So on router 1, we're going to see first enable, well, it says it's router 0, so let's change that to config T host name router. Okay, now exit. I'm going to do a show command right now. Show IP interface brief, just to see what is assigned to what. So here we have gigabit 168.40.0.1. Okay, on gigabit 001, that's correct, and 192.168.10.1. Okay, let's see the subnet mask. When these are to the 25 network, so show interface. So gigabit 000, that's to the 24, and 001 is to also to the 24 subnet mask. So let's verify this is in, oh, right here, 001 is in up down, so we gotta bring it up because it's administratively down, meaning that to fix this we're going to config T interface gig 0-0-1 no shutdown. Okay, so now I'm going to go and show IP interface brief. Okay, it's still in an up down, so let's see here on interface config show interface brief, see if on router 5, actually let's go like this so we don't get confused. So router 0 I had to change to router 1, router 4 I'm going to change to router 5, host name, sorry, global config mode, host name, router 5. Okay, now do show interface brief, do show IP interface brief. Should show us from that, and it's up, and it is out. Okay. So gig 000 is administratively down, connected to router 1. So gig interface gig 0-0-0 no shut. Let's change to up, and we are good. Okay, so connection is stable there, and let's see if we can end and ping 192.168.10.1. And okay, so alright, so it is successful. Let's try it again, and same thing. 3 of 5. Okay, we're just gonna give it a minute. Success rate should be at least 80%. Okay, that's good. Okay, well, that's up. So it looks like all the links are connected. Now we're gonna verify the routers. Device name router 3, device name router 1, device name router 4. Okay. name on all of these. Make sure we're talking about the right thing when we look at the CLI command, because it can get real confusing real quick. In a real world setting, you gotta know which router is which. The topology can say a lot, but once you go into command, you don't really want to make sure you're working on the right one. So host name router 3. Okay, let's do that for router 2. Config T enable config T host name router 2. Perfect. Okay, so let's see here. Let's go do show IP interface brief, and 192.168.10.2 is good. 192.168.20.1 looks good. Okay, go here, then 20.2 and 30.1. Do show IP interface brief. 20.2 on the gig 0100, perfect, and 30.1, perfect. Okay, and 192.168.30.2 is also, let's see, show IP interface brief, and yes, it looks like everything is in order and configured how it's supposed to be. So now we can start on OSPF. So first things first, what is OSPF and what does it do? So open shortest path first. So instead of doing hot counts such as RIP and everything else, it has a metric system in order to go from one network to the other as quickly as possible, and it has failover, and we're going to go through that right now. So gonna configure our first router, which is router 1. So pretty simple, configure terminal, then router, OSPF, and then 1 is the process ID. Okay, now the router ID is 1.1.1. Oh, sorry. Dash ID. There you go. So that is how to configure the router ID on OSPF. Now we're going to do network. We're going to add all the networks we wanted to connect to. So we could technically summarize it. With a wildcard subnet mask at 192.168.255.255.0.0. So we'll do network 192.168.0.0. So 0.0.255.255. 0.0.255. Okay, and then the area is going to be 0. They're all going to be in the same area in order for this to work. In order for OSPF to work, all the routers have to be in the same area in order for them to communicate through that protocol. So do that, and all the routers have to be configured the same way with the same process ID in the same area. So let's do that. So I'm going to do that with PT router OSPF OSPF1. Okay, router dash ID for 2 is going to be 2.2.2.2. Router ID, and then the network is going to be the same as all the other ones. 2.168.0.0, and then it's a wildcard subnet mask. So it's everything. It's like any other subnet mask, just like backwards. So regular subnet mask of 192.168.0.0 would be 255.255.0.0. Wildcard is just flip it pretty much. And then the area is 1, and enter. So that right there should establish. So really, what I'm going to do is go to a notepad here and just copy and paste this, which would be let me see here. Actually, let's do it on here. So if I just place note right here, so I would still have to do everything else the same. I'm just gonna do the network portion, which is really what's taking me the longest, just to sort of quickly go through this. 0.0.255.255.255. No, sorry. Got a little confused there, sorry. Area 1. So I'm just gonna and copy and just leave that there, and oops, gotta go back to click. Okay, so look, mismatched area ID. Okay, so there's a mismatch area. Sorry, area ID is mismatched. That's why I didn't got brought up. So area. So let's just go back and then do no network area 0. Clear that, and then network area 1 there, and that should establish it. Oops, sorry, that should establish it now. So we're gonna go here. I'm gonna go configure router OSPF process ID 1, and then paste what did the router ID, which is 3.3.3.3. Enter, and then we're gonna paste here. So, oops, sorry, paste right there. Bam. I'll bring that back up, and then same thing here. Router OSPF process 1. Oops. OSPF process 1. Enter. Router ID 4.4.4.4. Enter. Then paste. So it's a little similar to static routing, a little bit. You just don't have to go through the trouble of building static routes per network and all that. Although you can do network summarization, but it wouldn't find the shortest path, and there's no failover. So let's see, router OSPF1, router ID 5.5.5.5, enter, and then paste. There we go. So from qubits, process ID 1, 4.4. So it's learning its neighbors right there. Learn 1.1.1 and 4.4.4. Okay, so we just gotta wait for it. Okay. So So this learn this neighbor, the 5.5.5 and 2.2.2, okay. So once it is done loading, I'm gonna show here. Show IP OSPF. There you go, OSPF. It has a router ID. It has 2 neighbors, and let's see if we can ping. Let's see if we can ping router 4 at 192.168.30.2 interface. 168.30.2 interface. 5 out of 5. Okay, so let's go into simulation mode and see how that worked. So as you can see here, let me move my face. You can see here, it's a protocol it's using is OSPF, and you can see it delivering the packet. It is going through router 5, and that is the quickest way for it to reach router 1. It did not take the route through 3 or 2. It decided to go through the shortest path first, which is router 5. It's only 1-2 hops, and also, you know, it takes into account other things which we'll talk about a little later on. But that is basically how to configure OSPF. A lot faster, and we're gonna do a little failover test to see what happens if we shut down an interface and what route it would take if I shut down interfaces gigabit 0-0-0 or 0-0-1 to get to router 5. So just go here, go end, okay, and then fig T, interface gigabit 0-0-1. Shut down. Okay, let's say that's down. It still went through OSPF, but it took a different route. So it went through this route. You see that? It did not take this route. It actually went through here to see if it can get down here. So if I ping, should be successful, but it'll take a different route. Give it a little bit more time. So if we go back to router 1, things should be successful. so our static routes are still up. So here's the thing. I wanted to have exclusive use of OSPF. So you can have static routes, no OSPF routes, but for the sake of OSPF, we are going to unconfigure these static routes. That way, it'll go through OSPF only. So let's do this. Configure terminal. So config T. No IP route 192.168.10.0.255.255.255.0 via 192.168.30.1. So this is all kind of like a cheat sheet here. If you look at it here, it pretty much tells us how it's getting these IP routes, and then we can just, you know, put in all these commands, little shortcuts. So do no IP route for the 20 network, which is via the same thing. All I got to do here is change this. That is good. And to the 40 network, same thing. So to the 40. And then it's also via 50.2, so so if you go back, it'll only do OSPF now. As you can see, it already changed that. It went back to exclusively OSPF. So if we look at it now and show IP route here, OSPF, and then it's directly connected to these other networks. But that, I mean, honestly, the only layer 3 protocol that's going on here is OSPF here. So let's make sure we don't have any other static routes on any other interfaces. And just shut those down as well. So 192.config T, no IP route, and these are static routes that I'm shutting down. You'll see that in another video, but basically the easiest way I found that I have learned this is through you know, learning the static route way and then adding this dynamic protocol, which definitely is easier for me. So 255.255.0, okay, and then via 192.168.20.1, no IP route, hold on, 255.255.0.0, sorry. Then no IP route, same thing, but it was learned 30.2 as well, so we can shut that down. And we should be good there as well. Okay, so and then show IP route again. There. Only local, direct, connected interfaces, and oh wait. Oh, whoops. So my mistake here. I didn't see the 10 there. So .20.1. Sorry, that is no IP route 25. Consistent. Okay, let's see here. So 192.168 IP route 192.168.10.0 255.255.255.0 and 192.168.20.1. Okay, so I guess this is why the network engineers make the big bucks, because attention to detail. You don't want to shut down the wrong route. So right here is okay, so we don't got to worry about that. We're just gonna end here, and then that should be it. And bam, there, no static routes. Perfect. So no static routes here. Do the same here. So that's loading full. So it's still running that pane. You can see the connection is being done through OSPF, and we're gonna bring the connections to router 5 up in a bit and see what happens then and how quickly it changes. So it does have failover, as it static route would not. We would have to have a route by other means or a different connection to it directly from another router, statically routed through every single one that isn't directly connected. So let's see, and here, and show IP routes, and right here we have another static route. So config T, okay, no IP route 192.168.68.0.0 255.255.0.0 because it's to the 16 subnet mask, so 192.168.10.1. Yeah, that, and same thing, but this is .20.2, and that's and or do show IP route. And there, nothing but OSPF and local links. Perfect. Show IP route. And we have 1, 2, 3 static routes. So 192.168.20.0 255.25. What am I doing? Sorry. Config T. So no IP routes 192.168.20.0 255.255.255.0. So this is connected to the 192.168.10.2. And it is, do that same thing for the 30 because it's the 24 subnet mask, and connect via the same interface, and to the 50 which is to 10.2 and 40.2. Do show IP route now, and bam. Okay, now we're gonna do, let's see, it's still running OSPF. So look, it's fail proof. So and show IP route and one static route. So no, config T, no IP route 192.168.0.0 to the 16, so 255.255.0.0 via 192.168.40.1. So end do show. Oops. Config mode, so show IP routes, and we're running exclusively OSPF. So We're gonna bring this interface back up and see which route the packet takes. So, config T. Interface gigabit 001. No shut now. And let's see what it does. Status is changed to up. And let's see what route it takes. And show IP route. And let's see if OSPF is back up again. Okay, let's see. Oh, there's still the one static route. What happened here? Config T, no IP route 192.168.0.0 255.255.0.0 via 192.168.50.1. Okay. Do show IP route now, and great. So connected to all of the networks via OSPF 10.10.10, the 10 network, the 40 network, 50 network, the 30 network, and the 20 network. So looks like all is well. Is OSPF back on? And let's see, there we go. OSPF back on router 5. So a little bit of a watch, but it's well worth it. We went over OSPF and a little bit of static routing. So I hope you all enjoyed this video, and hope everybody has a good day. Thank you.